Hello everyone, my name is Caroline and my partner is Liana. In this video, we will present to you on the flow analysis at Sungai Linggi tributaries. As we may know, most catastrophic phenomena like river flood were often known to strike urban areas. Excessive rainfall in the basin is the main reason of flooding in the river system of a tropical region such as Malaysia. Many have died or suffered property damage as a result of the flooding. There are several areas within the city of Seremban that have been experiencing flooding due to the high flow in the Linggi River basin, especially during the monsoon season. For example, the city of Seremban has been severely affected due to the heavy rainfall intensity since the year 2007 until 2011. Thus, control actions are needed to be taken to control the flooding to reduce the flood damage. Therefore, this study is essential to solve the overbank flow of the Linggi River tributaries through the application of the head-grass river system by section modification and effectiveness of the channel. The objective of this project is to perform steady flow simulation for the Linggi River tributaries to analyze the effectiveness of drain using head-grass river analysis system, to solve overbank flow by using section modification, and lastly is to estimate the cost of this project. The study area of this project is located at the major waterway in the state of Negeri Sembilan. The Linggi River discharges to Strait of Malacca through an outlet in Port Dickson, which is located approximately 53 km downstream from the city of Seremban, which is the commercial and administrative capital and the major city of the Negeri Sembilan. The watershed of the Linggi River is highly urbanized and densely populated. Based on the data provided by the Department of Irrigation and Drainage in 2010, a river covers a total area of catchment area about 523 square kilometer, while the main river is a length of 43.8 kilometers, and the highest monthly rainfall precipitation experienced by the river is up to 86.7 millimeters. The Linggi River is consisted of four sub-basins which are Linggi, Pedas, Rembau, and Siput, with a total of 32 major tributaries, as shown in the figure. Next, I shall explain about the methodology of this project, including the selection of the data type of analysis, and the justification and procedure of the modeling and analysis. There were two input data, which are the geometry data and the discharge data. The geometry data included 9 cross-section data along the channel, which were channel 0 meter, 100 meter, 300 meter, 500 meter, 800 meter, 900 meter, 1000 meter, 1050 meter, and 1177.5 meter respectively. The left and right bank of the cross-section were also entered based on the tables. Head-grass software was used to model and analyze the river. One-dimensional steady flow analysis was used as only X and Y data were provided. However, this analysis of one-dimensional steady flow is similar to two-dimensional steady flow when computing the water surface elevation analysis. The Manning formula was used to estimate the Manning coefficient of roughness along the watercourse of Linggi River at different water levels. The values will vary depending on the condition of the bank. The Manning value for channel 0 meter until 800 meter is 0.027, whereas for the value above 800 meter is 0.05. To analyze the effectiveness of the channel, the recorded discharge of Linge River for the next 5, 20, and 50 years were also tabulated and input into the Heckler's model. The unsteady flow analysis cannot be used as there is no inflow hydrograph data routed by the model. It is time component, therefore it is not significant in flood analysis. The recorded discharge for the next 5, 20, and 50 years were as shown in the table. Next, I shall briefly explain and describe about the procedures of modeling and analysis using the Heckler's River Analysis software. Firstly, for the preliminary part, we start by creating a new project. Make sure to save into a different folder so that we can locate the folder easy. Next, we have to set the unit system into metric system. Then we create the ridge schematic using the river ridge and junction button in the cross-section windows. The cross-section data of the realization based on the table just now will include from upstream until downstream. The flow profiles and flow rate for the next future of 5 years, 20 years, and 50 years were added into the steady flow data editor. The boundary was assumed to be subcritical flow regime, so the computation will begin at the downstream end. After the geometry and flow data were established, the Heckler's model can be executed and the steady flow analysis and simulation were computed automatically by the software. There were several methods available to view the Heckler's output. To view the cross-section of the channel, select the View Cross-Section from the project windows. And you can see the cross-section for each channel at different levels. The modification was started by interpolating cross-section between two surveyed sections. Then the left and right banks station were changed. The channel design or modification was selected from a tool menu of geometric data windows. The template design was chosen before the value of effective depth, channel depth, bottom width, side slope, and Manning value were entered. Templates were designed at every reach. To display the cut and fill volume of cost estimation, we can try to click the cut or fill summary table button. Finally, once the desired channel modification data have been entered and we have obtained our desired ridges, the cross-section can be checked again and compared with the previous initial one. This step will be further explained by my partner Intan in the result and analysis in the next slide.
Hi, Assalamualaikum. My name is Intan Nurliana binti Zainal. I will explain briefly about what our project going on. I will continue my part from my friend. Okay, this is, as you can see from the slide, This is the river profile. For our group is C17. So the challenge is started from 0 for the downstream, 100, 300, 500, 800, 900, 1050 and 1177.5. This is the upstream. Next, for the modification of the drainage of the open channel, after I've been plotted the river profile, there is some overflow of the water out from the drainage. So we took all the information from the data given. We took the discharge for 5 years, 20 years and 50 years. For the drainage, it difference respectively between all the drainage and the value stated here. As you can see here, I got the modification template. First one, the modification template is for the channel depth. I took 20, bottom width is 7 meter, side slope is 0.1 and the meaning value is 0.027. I take the trapezium shape for the modification, and the second template is the channel depth is I took 100, bottom width is 15, side slope is 0.1 and also the meaning value is 0.027. As you can see here, this is all the modification I did. For the center station template, this is the first template and this is the second template. You can see I stated here, and the fixed elevation for the stable and flat bottom of the river. Okay, next, as you can see, this is the before modification and this is after modification for 50 years. I did all 9 chainage, as you can see. All of these because they have some overflow of water. So as you can, we can go back from the start. All the water and the drainage, I took more for excavate to avoid the flood to happen. And I estimate this one, the drainage will be more than 50 years if the flash flood does not be improved. So as you can see, for the net volume total, this is the cut volume. Basically, all the drainage have been cut out to fit all the water from overflow, and the total cut and fill is 35,921 meter cube. So this is all the criteria to calculate the cost for cut and fill. So the final cost is 8.6 million approximate. So I'll come to the conclusion of our project. The proposed channel was estimated to be at cost at, like I said just now, 8.6 million, and the total amount of cost is due to modification of the design of the river by using the concrete design base. This is will take more cost, and this so happen is to ensure the flash flood around the area will not occur over again, and I estimated it will be more than 50 years. And finally, it also due to river modification for the long-term project, which is more than 20 years. Thank you very much.